Welcome guys, and today we're back with another USACO walkthrough. We're going to be continuing the 2018 January contest today. It's going to be great. Let's jump in. Alright, let's do this. So let's scroll down to the bronze division. We did this problem last episode, and we're going to continue this division contest thing. Let's click it. Alright, so I've done this problem before. It's pretty hard, or it's not that hard, but it takes some time to work out. So let's start reading, and I've decided to reduce the time of my videos. I'm going to speed through this reading and explaining of the input and output formats. So I'm going to spend more time explaining my thought process and possible algorithms I can use. So let's speed through this. Farmer John has opened a swimming pool for his cows, figuring it would help them relax and produce more milk. To ensure safety, he hires N cows as lifeguards, each of which has a shift that covers some continuous interval of time during the day. For simplicity, the pool is open from time t0 until time t1000 on a daily basis, so each shift can be described by two integers giving the time at which a cow starts and ends her shift. For example, a lifeguard starting at time t and ending at time a lifeguard starting at time t4 and ending at time t7 covers 3 units of time. Note that endpoints are points in time. Sorry, my English is really bad. Alright, so Farmer John hires N cows as lifeguards. A day is 0 to 1000, and a shift is described by two integers, and the amount of time that they cover would be the difference of these integers. Let's keep reading. Unfortunately, Farmer John hired one more lifeguard than he has the funds to support. He's kind of poor. Given that he must fire exactly one lifeguard, what is the maximum amount of time that can be covered? That can still be covered by the shifts of the remaining lifeguards. An interval of time is covered if at least one lifeguard is present. So Farmer John is going to fire one lifeguard, and we're going to find the maximum amount of time that can still be covered by the shifts of the remaining lifeguards. So the input format is going to be n first, which is in this case 3, and each of the next n lines describes a lifeguard in terms of two integers. So these are all describing lifeguards. In the range 0 to 1000, giving the starting endpoint of the lifeguard shift. All such endpoints are distinct. Shifts of different lifeguards might overlap. So these are just shifts of lifeguards, and they can overlap. And output is going to be the maximum amount of time that can still be covered if Farmer John fires one lifeguard. Okay, let's just work out this test case real quick. Alright, so if we scroll down, we can see that the sample input has 3 lifeguards, 5, 9, 1, 4, 3, 7. So if we plot this on a number line, we can see the exact amount of time that each lifeguard covers. So let's just plot them out. So first one is 5, 9. So let's put them there. So here and here. Our second one is 1, 4. And our third one is 3 and 7. So if we see here that 1 is the minimum and 9 is the maximum. So in this case, the maximum amount of time covered by the lifeguards would be 8. But Farmer John needs to take out one lifeguard, so let's just take out the first one. In this case, 5, 9. So we'll just move 5 down here and 9 down here. And we see that we have 1 and 4 and 3, 7 still covering. So 1 minus 7 would be 6. So let's write that down real quick. So we have 6. Let's continue. So we can put these back. And now we can remove the second one, 1 and 4. Let's just move this over here. So you see here we have 3 and 7 and 5 and 9. So in this case, the minimum is 3 and the maximum is 9. So in this case, it would be 9 minus 3, which is 6 again. So 6 and equals 6, so we don't need to write down another 6 as it's not it's not greater than 6 itself. So let's keep going. Remove this back. And move this back. And finally, we take out 3 and 7. Let's move these down. And here we see that 1 and 4, that's a 1 and 4, that's a distance of 3, and 5, 9, that's a distance of 4. 3 plus 4 would be 7. So in this case, 7 would be the maximum. And let's see what they have for us. And indeed, 7 is the maximum amount of time covered by the remaining lifeguards. Alright, so now that we have calculated this sample input, we need to find a way to optimize it and put it into code form. Now, if we go back to our calculator suite, we can see that we need to find a way to calculate the overlaps between intervals of a lifeguard. Well, one thing we can do is create an array of length 1000 at least, as that's the maximum amount of time on a daily basis. And for each time point, we can see whether a lifeguard is covering it. So what we can do is mark all of the elements in the array to zeros. And for every lifeguard, we skip that lifeguard and we fill in all the other lifeguards' intervals. And we run through the array and we see whether the element is 0 or not. If the element is 0, then that time frame is empty. If it's not 0, then it's filled. And we count the maximum amount of filled elements, and we can go from there. So let's just start coding. So if we open our IDE IntelliJ, this is the same project that I did last time, and we're just going to create a new source file. This time the input and output files are called Lifeguard. So let's just create Java class, and let's just put Lifeguard. Alright, now that we have our lifeguard, we can just do public static void main. Sorry about that. And that's just like a little shortcut, and we also have to throw the IO exception, like we discussed earlier. Alright, now we can copy and paste our buffer reader and print writer from this project over here. And we copy and paste that. And it imports our Java utility right here. So now that we have our lifeguard, we need to change these to lifeguard.in and lifeguard.out. Sorry about that. Alright, so if we go back to our problem, it's called lifeguards. Sorry about that. If we go back to our problem, we can see that the first thing we need to read in would be n. So let's do exactly that. If we go back to our IDE, let's read an n as an integer, so it would be int n equals integer.parseInt, and we'd br.readLine. So now we have read an n, we need to find a way to read in the intervals of the lifeguard. So we can see that these are the 5, 1, and 3 are the start of the intervals, and 9, 4, and 7 are the end. So instead of using a 2D array, for simplicity, we can just create two separate arrays. So let's create one array named inStart. So it's going to be filled with integers, and it's just going to be a new int. And since there are n lifeguards in each case, we're just going to set the length to n. And we do this again for the end. Alright, now that we have declared these these arrays for reading in, we need to actually read in these things and put them into the array. So one thing we do now is read in the input and put them into the array. So we create a for loop that runs n times, as there are n elements in each array. And now we declare a new string tokenizer, as there are multiple tokens in each line. Okay, now that we have finished writing our string tokenizer, we can declare our variables and plug them into the array. Sorry, not declare variables. Initialize the I and put them into start. So start I equals. Sorry guys, I'm kind of bad at explaining coding concepts. I try to get better, but I try to explain as most as I can from normal perspective instead of using high quality coding language. So start I equals integer.parseInt, and then st.next token. So this, and now we do end, so it's end I. So if you don't know what this code does and you're new here, st.next token simply reads in the next character in the line, and we declare a new string tokenizer every line, as string tokenizers can only go as far as one line, so we have to go to the next line each time we loop. So now that we have read in our input and put it into our arrays, we need to declare some more variables. So as you know, as we talked about, we need a max. This is what we're going to print or return back into the system. So in max equals 0. And we also need to declare the array for the time frame. If we go back to our problem, we can see that the time frame is based from 0 to 1000, and that's how we're going to count the amount of empty spaces or the amount of filled spaces and see which one is the maximum. So it's just going to be an array of, let's just call it frame or time frame equals new int, and it's going to have a length of 1000, as that's the 0 to 1000 is the time frame within a day. Sorry about that. I'm gonna add those two square brackets. Alright, so now that we declared our variables and written our input, it's time to get into more coding. So if we look here, all we need to do is run through this input that we have stored in our arrays, and for example, if we read this one, we ignore it, and then we fill in all the intervals for 1 and 4 and 3 to 7. Basically, for each round, for each loop, we run through one of these intervals. We don't do anything, and we fill in all the other intervals, and we count how many intervals. We count how many elements are filled, and then we simply clear the array of zeros. So if you don't understand that, let me try to optimize it for you. So we're just going to delete everything here. Alright, so let's just delete these axes to make it more no grid. And let's just say let's just do some text here. So let's do text. So let's just say that we have, so in this case we have 5, 9, 1, 4, and 3, 7. So in this case, we would run through this and we would skip 5, 9. So in this case, let's just have an array here. And it's going to be 0, 0, 0, 0, 0. These all represent points on the time frame. And that should be about it. And this goes on and on. So if we ignore 5 and 7, we fill in 1 to 4. So in this case, all of these would be filled with 1s. We're going to add 1 to each element that we fill. So in this case, 1 to 4 are all filled. And now we need to fill 3 to 7. So 3 would be filled here, and 1 plus 1 would be 2. And these would all be, this would be 2 as well. However, this would be 1. So this is 1, 2, 3, 4, 5, 6, 7. So you see here that we can count overlaps because even despite being different numbers, they're still not 0. And we can just count the amount of zeros and subtract from the original sum. So let's just do this. So we can just say that if this element is not 0, we add 1, and then we add 1 to our count. And if that count is greater than the maximum, then we set it to the maximum. Alright. So let's go back to our code. And so since we're running through end of lifeguards, we're going to do a new loop. So for int I equals 0, I is less than n, I plus plus. And then within this loop, we need to loop through each of these we need to loop through the elements again, as we're going to skip one of those elements. So we're just going to do int j equals 0 equals n, j is less than n, and j plus plus. So if you don't know what I'm doing right here, we're going to loop through these this input. However, for every time we loop through one, in this case, if we loop through 5, 9, we need to check if all the other ones are. We need to plug in all the other ones into our array, and we do this for every single one. So if we read in 5, 9, we ignore it and we record all our intervals on our array for 1, 4, and 3 to 7. If we read in 1 and 4, we ignore it. We read in the intervals for 5, 9, and 3 and 7. If we loop through 3 and 7, we ignore it, and then we add all the time frames for 5, 9, 1, 4. So let's just continue. So we can add some comments here. We ignore one lifeguard, add 1 to remaining interval time frames. Alright, now let's keep on going. So how do we ignore one lifeguard? Well, we can just do if j is not equal to I. So what this does is that if they're not the same, so basically, let's just say that I is 0. So in this case, I would be reading this one. And j also loops through the whole thing. So if j doesn't equal this, then it's not going to do anything. However, if it is going to do stuff for 1 and 4 and 3, 7, and that's exactly what we want. We want to ignore one and do things to the other ones. So if we go back, we can just do if j is not equal to I. In this case, we're saying if the one we loop through here is not equal to this one, basically saying if we're looking at a different interval of a lifeguard, basically the one that we're not ignoring, we're going to add one to our num cover. So we're gonna do int k equals start j. If you don't know what I'm doing, as you know, we declared 2 arrays for our start and end, and each lifeguard's interval is going to be the difference between 5 and 9. Basically, where it's going to loop from 5 to 9, or in this case, since we're ignoring 5 to 9, we're going to be looping from 1 to 4 and filling it all in with 1s. We're adding 1 to each element. So it's going to be int k equals start j, and k is less than end j, k plus plus, and num cup. In this case, we're going to do time frame k plus plus. So now that we have the basic code to read in the lifeguard's input and then utilize the input, and basically we're ignoring one and adding one to all the other ones, and now we gotta count them. So let's make another loop for that. Oh yeah, beforehand we need to declare a variable to count how many elements are covered, basically are not 0. So int covered equals 0, and this is basically a temporary variable that we're going to set to max every time. So let me scroll down real quick. So it's for int j equals 0, j is less than 1000, and j plus plus. I'm just using j because it's in the same place as the other j, so we can still use it, but we can't use I. So I just usually use ijk, and then if that doesn't work, if there's still more, I go abc. Or I can go xyz. You never know. So let's just put a comment here. This is going to be counting the amount of covered elements. In this case, the elements represent time intervals, I suppose. let's just say, wait, what do they call them in the problem? So each shift into, let's just say units of time. Sorry, I need to sneeze real quick. Oh, never mind, actually. Of cover elements, in this case, units of time. And then we're going to count them up. So in this case, we're going to do an if statement. If num cover is j, and oh sorry, not num cover, covered. If num covered j is greater than 0, so basically what we're saying, if this element is not 0, basically it's covered by a lifeguard, then we add 1, and we add 1 to our covered variable. Oh sorry, not covered, we're going to do time frame. Sorry about that. So we're running through time frame, and basically that if the time frame element is not 0, basically means it's covered by one or more lifeguards, then we add 1 to our variable. So let's go down more. Okay, let's go down here, and then we need to declare another for loop, basically saying if our temporary variable covered is greater than max, we're going to set it to the maximum, and we're looking for the maximum here. So we're just going to do, actually we don't need a for loop, we're just going to make a simple if statement. So if covers is greater than max, so if covered, then max equals covered. And right to here we're pretty much done. Only we have one more thing to do. If we don't clear our original array time frame to 0, we cannot do any more. We can't really do the for loop again, as it's just going to mess up our calculations even further. So in this case, we're just going to clear, or basically fill the entire array with zeros, basically emptying out the lifeguard time frame. Since we're doing new ones every time, basically we ignore this one, we fill in the rest with 1 4 3 7. We still need to, when we do 1 4, 5 9 can't be not filled, so we need to ignore that. So we need to fill arrays.fill the entire array with zeros, basically cleaning up our interval recorder. So arrays.fill what is it called? Time frame. And it's going to be 0. So we're filling it all with 0, and we need to import this. And yeah, for now we can just get out of the for loop and return max, basically pw.println. So pw.println max. And now we do pw.close and br.close. So let's add some more comments. So basically this is for cleaning up the time frame array, as we need a fresh array to ignore each lifeguard each time. So now we can just submit to USACO. So I'm going to find my file real quick, and we're going to submit together. See you later. Alright, see you soon. Alright guys, I found my file, and we're just going to submit it now. So it's just going to be grading now, and I'm pretty sure this is going to work. Yep, as soon as we see it's grading, and we have passed all the test cases. So thank you guys. If you enjoyed, please subscribe. It's free, and you can always unsubscribe later. So thank you for watching. I'll see you next time.